system of parallel non-concurrent forces is acting on a rigid bar AB, as shown in figure. This is the rigid bar AB. Okay, so parallel and non-concurrent forces. Okay, is the parallel forces. So, but acting in the different. Okay, direction is different. Okay, so at the rigid bar AB, reduce this system of forces to okay a single force R and couple at A, the first one. The next, a single force R and couple at B, a single force R and couple at C, a single force R and couple at D, a single force R and its position. Okay, there's a resultant force acting in which distance from point A. Okay, want to find the distance of resultant force. This is the last one. First one, we want to find the forces. Okay, reaction forces. Okay, so first resultant force. Okay, so resultant force of from given beam is okay is the upward is positive and downward is negative. Okay, consider negative one sign. Okay, this is the one. So upward is positive, so 50, downward is negative minus 200, downward is 100 minus upward is 70 plus 70. So it is a positive forces 50 and 70 is 120. So 200 minus 100 is the 300. Okay, minus 300 is equal to resultant force is minus 180 is the downward direction. Downward is the downward direction. Okay, is acting in the resultant reaction force. Resultant force is acting downward. Okay, is negative sign indicating only downward reactions. Okay, then next to find the single force. Okay, single force are under couple at A. So already single force is 180 already find out, and couple at A, we want to find the couple at A. Okay, so moment of about point. Okay, is the formula is generally using F into D. Okay, F into D, force into distance. So MA, so moment of point A here clockwise. Okay, the force acting in the clockwise is -1, counterclockwise is +1. Okay, clockwise is negative and anti-clockwise is the counterclockwise is +1. Take moment about point A. Okay, this is point A, 50 into 0. So our point force moment is force into distance. Force into perpendicular distance is moment. Okay, 50 into no perpendicular distance. So distance is 0 at point A. Next, take force 200. 200 is clockwise direction is negative. Distance perpendicular distance is 1. Okay, from A. Okay, 200 into 1. Then next 100 is the also clockwise direction. So negative sign is 100 into distance is 2 plus 1 is 3. Okay, distance is 3. Okay, next, so 70 is the counterclockwise direction. Okay, is acting in the counterclockwise directions. Okay, is the positive, and distance is 1 plus 2 plus 1 is total distance 4 from A. So 70 into 4, so multiply this one. 50 into 0 is 0, 200 into 1 is 200, 100 into 3 is minus 300, 70 into 4 280. So 280 minus 500, so MA is equal to minus 220 Newton meter is the clockwise direction. So moment at the clockwise. Okay, then next to find the single force R and couple at A. Single force R is okay already known. Okay, minus 180. Okay, so also minus 180. Here also single force is minus 180 for all cases. So couple at B is at point B. Okay, we want to take point B. So is moment about point B. Okay, so about point B, so 50. Okay, so 50 is the clockwise direction. Okay, 50. Okay, 54 is also clockwise directions, otherwise minus 1. Okay, flag minus. Okay, 50 into here also no need 1, here also put minus 50, is also clockwise direction. Okay, clockwise 50 into minus 50 into 1. Okay, so next 200 into 0, so at the point 200 into 0, so is also clockwise minus 100 into 2. Here's anti-clockwise direction, 70 is anti-clockwise, 70 into 3. Okay, distance. Okay, at point B. Okay, moment about point B. So 50 into 1 minus 50 into 1 minus 50, 0, minus 100 into 2 minus 200, 70 into 3 210. So simplify this one, we can get the minus 40. Okay, Newton meter is also counterclockwise directions. Okay, next to find the single force R and couple at C. Okay, to couple at C, so take moment about point C. So here 50. Okay, 50 into clockwise direction 50, distance is 3, so minus 50 into, it's no need to minus. Okay, so minus 50 into 3. Okay, so next 200 into 2, so minus 200 is the plus, is the clockwise, this also anti-clockwise direction. Okay, this is anti-clockwise direction plus. Okay, the anti-clockwise direction plus distance, no need to distance. Okay, so minus 50 into 3. Okay, plus 200 into 2, plus 200 into 2. Okay, then next at the same point, so minus 100 or plus 100, no problem. So minus 100 into 0, this also anti-clockwise direction, 70 into 1. Okay, 70 into 1. Okay, so simplify this, minus 50 into 3 150, 200 into 2 plus 400, minus 100 into 0 0, 70 1 is 70. Okay, 470. Okay, 400 into 7 plus 70, 470 minus 150, mc equal to 320 Newton meter is a counterclockwise directions. Okay, positive is counterclockwise. Single force R and couple at D. So this is also known it, distance always positive. Okay, consider distance is positive one. So take moment about point D, is the clockwise direction is minus. Okay, this is clockwise direction, this 200 is the anti-clockwise direction, minus 200, so plus 200. Okay, minus 50 into 4 plus 200 into 3. Okay, then next is the counterclockwise direction. Okay, positive. Okay, 100. Okay, plus 100 plus 100 into 1. Okay, this is put like this. Okay, minus 50 into 4. Okay, okay, minus 50 into 4. Okay, minus 200 plus 200. Okay, distance counterclockwise direction, so positive. 200 into 3 plus 3. Okay, is here plus 3, 200 into 3 600, then 100 into plus 1. Okay, 100, so 70 into 0 is 0. So 700, 600 plus 100 is 700, minus 200 is equal to 500 Newton meter is a counterclockwise direction, counterclockwise. Okay, then a single force R and its position, a single force R and its position, to find the single force R and its position, this formula Rx is equal to sum of f of I and x into xi. Okay, this is R is the resultant force, this is want to find out the x distance of resultant force, fi force into perpendicular distance. Okay, so our resultant force is already find out, the minus 180 into x. So moment about point A, 50 into 0, so minus. Okay, it's a clockwise direction, so minus 200 into 1 is also clockwise direction, so minus 100 into 3 is anti-clockwise direction, so positive. Anti-clockwise is positive, it's a clockwise direction minus. Okay, so minus 180 into x equal to minus 220, so minus minus will cancel, so x equal to 220 divided by 180, so distance of 1.22 meter. The resultant force acts 1.22 meter from A. So this is the beam. Okay, resultant force. Okay, this is a beam, resultant force acting downward 220, around 220 from this is 1.2 meter, like, okay, resultant force. So 220 acting from A, okay, from A, okay, 1.2 meter to meter. This is the resultant force. R is equal to minus acting downward, so 1.22 meter from A. Okay, this is the answer for position of resultant force in beam. Okay, thank